In the previous lecture, we showed how limited comparisons between two single points are. Comparison of this month to last month, or the comparison of this month to the same month last year, and so forth. Shewhart control charts takes variation into account over time. So it takes the entire process, the behavioral process, into account. It takes into account variation. It concentrates on the behavior of the underlying process. It defines the voice of the process, and based on that we can extrapolate into the near future. The structure of a Shewhart control chart consists of it's essentially a run chart or a time series. These are the points over time. You have a central line or the average line. You have upper and lower control limits. So a control chart characterizes the variation into two types. We have random or common cause variation, sometimes referred to as noise or routine variation. This is the variation that produces points on a control chart that over a long period of time fall inside the control limits. As you see, they behave randomly between upper and lower control limits. The common cause variation stayed the same day to day, lot to lot over time. So these points are randomly behaving between upper and lower control limit. If that is present, we say that this process is in a statistical control, and its behavior is predictable in the near future within upper and lower control limit. This is the characterization of the variation. What that indicates that these points within upper and lower control limits are produced by the same system of causes. Nothing special, nothing unusual has occurred. The assignable or a special cause variation, sometimes referred to as signal or exceptional variation, is something special, not a part of the system of common causes. It is generally detected by a point outside the either upper or lower control limits. In this case, this value manifests special cause variation. In addition to the common cause variation, there is also something special, something unusual, something exceptional has occurred here that warrants investigation. Here we ask what happened, so we have to investigate this point. In the previous example, random variation, we actually examined the entire system of causes. In this case, this special cause variation gives us permission, gives us a signal as how to investigate this point. Something unusual has occurred. So Shewhart control chart characterizes the variation into two types: predictable variation, so that is produced by a predictable process; unpredictable variation, which is produced by an unpredictable process. The distinction between these two is very, very important. So the control chart is the voice of the process that communicates to us the behavior of the process. The confusion of these two, the predictable and unpredictable, common cause or a special cause variation, the confusion of these two leads to a very two costly mistakes. Mistake 1: interpreting noise as if it were a signal, interpreting common cause variation as a special cause. As in this example, is to treat each one of these points as though something special has occurred, as in our in-process inventory manager or management wanted us to do, explain the difference between this month and last month, or this month to the same month last year. So we essentially, what we are doing is we're treating each one of these as something unusual, and this variation and that variation demands explanation. We are treating common cause variation or noise as a special cause variation or signal. Mistake 2 is the failure to detect a signal when it is present, interpreting a special cause as common cause. A missed signal is an opportunity wasted. That is a reference to this point. To treat this point as common cause variation, in other words, to treat that as though it's one of these points. This is an opportunity missed. When you have a special cause present, that warrants investigation. The special cause may be present as a point outside the limit on the high side or on the low side. In either case, they have to be investigated. Oftentimes, a special cause has to be removed from the process, identify the causes, and the causes be removed. Sometimes a special cause is investigated and the causes are good causes, and we want to incorporate that into our process. So this is the structure of a control chart. Is, as mentioned earlier, is a run chart, a time series with some lines attached to it. You have the central line, which is the process average. You have upper and lower control limits. The chart that we often use in business processes is known as individual and moving range control chart, or IMR. This is the most suitable when data is collected periodically, as they are in business processes, daily, monthly, quarterly, etc. And this is how we calculate the central line, the upper and lower control limits. So going back to the in-process inventory, how the management demanded explanation between the changes in the July of this year to July of last year, or the year before, or June of this year. So 12% above last July, 27% above July year before, and 47% above June of this year, and demanded some explanation. We plotted those points over time, and these are the 3 points that are being compared. And if we place that on a control chart, we see that all the points are behaving randomly between upper and lower control limits. Nothing unusual, no special cause variation is present. Therefore, we say that this process manifests common cause variation, and all the points within upper and lower control limits are affected by the same system of causes. To interpret this chart, we say that based on our previous data on the last several in-process inventory, the monthly in-process inventory average is 20 tons, and the process manifests a variation that can fluctuate between 8.5 to 32, nearly 32 ton monthly variation. This process is predictable, and you can predict the behavior of this process into the future. On average 20 tons monthly, and you can behave or produce a value that is between 8.5 to 32. Perhaps you say that this is too much, it is too wide of a variation. Well, it may be. However, the limits are calculated using the process data. That is why this is called the voice of the process. This is the behavior of the process under current conditions. So the individual chart is the actual monthly variation. It is in a statistical control, and we have a process variation of 8.5 to 32, nearly 32 tons of in-process inventory. The management demands a range of the average plus or minus 20%. That's an area from here to there, about 16 to 24. Well, this is not. This is a part of the process. However, the voice of the process capability says this process is behaving between 8.5 and 32. If we want something narrower than that, then we have to work on the process to narrow the variation in this process. And that would be our improvement strategy. Or perhaps this average is too high and we want to reduce that variation. That average rather. So in addition to a point outside the upper and lower control limits, there are other detection rules that help us identify special causes of variation. Our textbook Understanding Variation is an excellent reference to better understand variation and understand Shewhart control charts.